In our last video, we learned the basics of graphing an angle in the coordinate plane. And again, if you're in standard position, which is what we're pretty much always going to be talking about, we have a terminal side, which is like in this picture would be the red side, and the initial side, which usually you don't even bother drawing, which is always fixed on the positive x-axis right there. So in this video, we're going to practice making some different examples, talking about like looking, okay, how many degrees is a different angle. I tried to color code this to make it easier on you guys. So in our picture here, we need to figure out how big the blue angle is in our picture, and we need to figure out how big the green angle is, and they're going in different directions. So if I look at my blue angle right here, I know I have 90 locked in from that first part right here. So it's at least 90, and I'm going all the way to right there. Well, if I would have made it all the way to the x-axis again, that'd be 180. But I actually have a 15-degree angle from here to here. So my blue angle is really going to be 180 minus that 15 that I didn't quite get to. So in blue, if I'm going in that direction, I'm looking at a 165-degree angle. If I was looking at the green angle instead, I have a full 90 from this. There's another 90, so I'm up to 180. And then this one isn't actually so bad. That's just another 15 on there. So 180 and 15 is 195. And since I'm going in the clockwise direction, though, that is a negative 195-degree angle. So I like taking these 90 at a time. You just kind of piece them together, and you can make sense of what's going on there. So both of those angles mean the exact same thing. We have a 165-degree angle and a negative 195. In a second example here, we're going to look for the measure of the purple and the yellow angles in our picture. Let's tackle the purple one first. So I know that the red is my terminal side right here, and that's somewhere in the fourth quadrant. We're down here in quadrant 4. I should mention, sometimes you'll care about what quadrant your angle is in. And just in case you've forgotten, these are our 4 quadrants right there. So my angle is in quadrant 4 right now. If I look back at my last example, the terminal side of my angle was in quadrant 2. So anyway, that's just a little side note there. If we're looking at our angle, first the purple side, we have locked in at least 90 degrees right there. We're up to 180 when we hit here. We even hit clear 270 when we hit here. We're 10 degrees past 270, it would appear. So that's going to make our total angle 280 degrees. Oops, I guess I should probably use purple for that. 280 degrees for my purple angle. 3 full 90s plus an extra 10 degrees. If you look at my yellow angle, it's kind of a weird situation here. Because on the yellow angle, what we did, we actually wrapped around completely. I'll trace over that in green right here. We already did a full circle, got back where we started, and then we went a little more. So it's more than like 360 degrees is just getting back to our starting point. We went a full 360 to get to here. Negative 360, and then we went some more. Well, if I would have made it all the way to there, that'd be an extra 90. But I didn't, I'm 10 shy, so I went an extra 80 on top of my full circle. Well, negative 360, I tack on an extra negative 80. That's going to make an angle of negative 440 degrees. And the degree symbol is important that you put on here. We're going to learn about a new type of angle measurement that it's got to be really clear you have the degree sign to show the difference. But that yellow angle is negative 440. All right, we've got one more problem in this video, and I'm going to show you guys how you can draw an angle in standard position. We want our angle here to be 260 degrees. The first thing you should ask yourself is, what quadrant is my angle going to be in? Well, if it says positive 260 for one thing, you're going in this direction. You're going clockwise. So I'm going to look right here. If I were to go right here, I'd be at 90. If my angle was there, I'd be 180. If I made it here, I'd be at 270. So I'm not quite at that spot, because that would be a little too much. That'd be 270. So if I was just to eyeball this, and really that's what I'm going to do right now, my angle is going to be something like right here. And I'm going to show that that is the angle by showing the direction that I'm moving like that. That is a 260-degree angle, or close enough. I assume it's about 10 degrees right in there. Now, if I wanted to draw this precisely, like I really wanted to use a protractor on this, I can't measure 260 degrees on a protractor. Protractors only go up to 180. So what I would have had to have done there is realize, well, okay, if it's 260 degrees to go from here to here, that means this part here has to be 100 degrees. So I would have aligned my protractor and measured my 100-degree angle right here. That's if I wanted to be super precise with it. It's debatable. It's not always going to be the case where you need to be that 100% accurate. But if you wanted to get the actual angle, you would need to use a protractor backwards like that. So that is how you measure an angle and draw and label angles in the coordinate plane.